OpenAI 在今天凌晨的时候发布了他们的最新模型 O1， 这个跟原来传闻的新模型叫 Strawberry 这个名字不太一样，它重新起了一个名字叫 O1， 我们一会儿再来介绍它为什么起这样一个名字啊。就简单来说，这个模型的话，他们是认为这是一个更适合去进行复杂任务推理的模型，能够解决比以前更困难的一些科学编程以及数学方面的问题。按 OpenAI 画的饼呢，是今天开始 ChatGPT Plus 用户和 Team 用户都能访问 ChatGPT 的这个 O1 模型，然后以后免费用户的话可以使用 O1 mini 模型。但是我实际看了一下官网，就是发现为的 O1 模型还并没有更新，这个也非常符合 OpenAI 的风格，每次发布会都画一个大饼下一个承诺，但是真正模型来的时间总是比实际的要更晚一些。之所以给这个模型命名为 O1， 是因为就是对于 OpenAI 来说，他们觉得这个模型在复杂推理任务上获得了一个重大的进步，代表了人工智能能力的新水平，所以他们将计数器重置为1。从这个视角来说的话，你可以理解为现在 OpenAI 它大概没有更振奋人心的所谓 GPT-5、6之类的这种新模型了，所以它只能用一套新的模式、新的规则对它的模型去进行命名。然后接下来我会带你一起去看一下这个模型究竟有什么新的那个能力，它在技术方面的各类表现究竟是什么样的。你如果对这种技术文档感兴趣的话，你可以继续看，如果你不感兴趣，更想去看实际演示的话，你可以看现在的屏幕去跳到对应的12个案例的各自的演示的时间。 OK， 那我们开始。首先 OpenAI 在技术文档里提到，这个在编程问题上 O1 有了巨大的这种领先，在一个 Codeforce 的比赛中能排名 89%， 然后在美国数学奥林匹克竞赛的这个预赛中也能排在美国的前500名，这个听起来还是非常厉害的，而且在物理生物学的基准水平上都超过了人类博士的水平。其实很多人都认为大型语言模型更像是一个文科生，但是我恰恰确实不这么以为，就是因为在生产一些创造性很强的文本上，像 ChatGPT 这样的模型确实没那么强的能力，但是它在推理能力上，它在解决很多逻辑的问题上，它确实更接近于一个高智能的人类，或者说一个很强的一个理科生。然后这里他是提到他们随着这种强化学习时间计算量的那个增多， O1 的性能在持续提高，而且这个训练方法和普通的 LLM 的这个预训练不太一样，我估计这方面的训练方式也是后续很多别的厂商，尤其是国内厂商学习的这个方向。然后在一些评估上面可以看出，它相比GPT-4o 有了非常巨大的这种提升，包括在数学水平、写代码水平以及科学问题的这些水平上，尤其是这个数学水平，这个提升能力实在是太夸张了，就是从 13.4 分提升到83分，以及在写代码的这个水平上，从11分提高到了89分。说实话，我后面会很期待Cursor，就是 AI 自动写代码的这个应用，到时候如果接入 O1 模型的话，它可能能实现比 Cloud 3.5 Sonnet 更强的这种水平。然后后面也可以看出，就是在很多非常广泛的这个测试上，不管是各种类型的考试，还是machine learning 的这些标准的测试，还有 PhD 的一些考试， O1 相比于原来的 4o都有非常大水平的提升，就是你可以认为这是一个标准的做题家，他在做题方面的能力提升非常的明显。 然后这里还有一个 train of thought， 就是原本这种思维链的模式是我们需要通过 prompt 提示词技巧去激发模型去获得的。我在之前的视频里也演示了我们应该可以通过什么样的提示词去激发 ChatGPT 或者其他模型的这种思考的能力。然后从现在的这篇技术文档来说的话，你会发现 OpenAI 它通过这个模型，它把思维链进行了内化。当用户问到一些相对复杂的问题的时候，你看左侧和右侧有一个对比，就是一个很奇怪的解密码的一个问题，左侧是4O，右侧是这个 O1。你会发现就是 O1 在思考的这个能力和思考的准确性上，相比原来的4O 都有了非常明显的提升，并且最后得到了正确的结果。而4O 的话，如果面对一些复杂问题的时候，即使你去激发它的思维链，它也没有办法去得到有意义的结果。所以你可以认为，就是现在的 O1 它能够去进行思维链的这个过程的思考，并且它的这个思考能力在智力上有一个明显的提升。接着在编码方面的话，就是他们的模型在2024年的国际信息学奥林匹克竞赛中获得了213分，排名49位，这我觉得是一个非常高水平的一个成绩。因为用的是2024年的竞赛，所以它应该在原来的训练模型中是不包含这些问题的，所以没有这种很多国内模型去跑分的时候这种过度拟合以及很多问题已经训练过的这种问题。还有在这个 Code Force 的这个水平上，你会发现就是 O1 就是现在 Preview 放出来的版本以及后面真正的这个 O1 版本都比 GPT-4O 有 50% 以上的分数的提升。但是有一些不一样的是，你会发现就是 O1 它好像更像一个做题家，就是在人类偏好方面，就是在这种写作还有编辑文本方面，它其实并没有比 4O 有显著的提升，只是说它在数据分析还有一些数学的计算以及编程的这个能力上，它的提升幅度非常的明显。所以就是你应该根据自己的任务需要去选择不同的模型。如果你想要写作的话，你完全可以用原来的 4O 或者用 Cloud 3.5 的模型，有可能会有更好的那种表现。而如果你是要去编程要去做数据分析的话，你可以用这个 O1 模型。等到时候这个 O1 出来之后，我也会去尝试它的编程还有数据分析以及数学的这类能力。好的，然后在思维链方面，他们目前会把这种模型思考的这个思维链去进行隐藏，一个是因为用户其实不需要看那么多的文字，另外一个是就有这种思维链的存在的话，对于模型的可解释性会有一个非常好的这种帮助。所以现在的思维链更适合来说是让 OpenAI 去理解它的模型是怎么运作的，以及它怎么去监管这个模型，让这个模型更合规。而对于普通用户来说的话，我们到时候是可以忽略那个思考的过程的。所以总结来说的话， O1 现在是 OpenAI 最先进的模型，以及他们会在这个模型的基础上去做一些进一步的迭代，并且他们觉得就是 O1 会在科学编程以及数学相关领域上做一些很强的这种提高和一些新的案例。我们确实可以期待一下 O1 发布之后，我们让它去帮助我们写代码去创建更多的产品。但是在写作方面的话，可能现在大型语言模型确实到了一定的瓶颈，要它写出比人类作家更好的文章，可能还是有一定的难度。然后接下来后面的话，总共还有12个就是 OpenAI 放出来的他们技术人员演示的使用 O1 去进行写代码或者去解难题的一些演示。你可以根据我这里 屏幕上的时间戳去选择对应的时间去进行观看。我们的这期视频就先给大家介绍到这。
All right, so the example I'm going to show is writing a code for visualization. So I sometimes teach a class on transformers, which is a technology behind models like ChatGPT. And when you give a sentence to ChatGPT, it has to understand the relationship between the words and so on. So it's a sequence of words and you have to model that. And transformers utilize what's called a self-attention to model that. So I always thought, okay, if I can visualize this self-attention mechanism and with some interactive components to it, it will be really great. I just don't have the skills to do that. So let's ask our new model, O1 Preview, to help me out on that. So I just typed in this command and see how the model does. So unlike the previous models like GPT-4o, it will think before outputting an answer. So it started thinking. As it's thinking, let me show you what are some of these requirements. I'm giving a bunch of requirements to think through. So first one is like, use an example sentence, the quick brown fox. And second one is like, when hovering over a token, visualize the edges whose thicknesses are proportional to the attention score. And that means just if the two words are more relevant, then have a thicker edges and so on. So the one common failure in most of the existing models is that when you give a lot of the instructions to follow, it can miss one of them. Just like humans can miss one of them if you give too many of them at once. So because this reasoning model can think very slowly and carefully, it can go through each requirement in depth, and that reduces the chance of missing the instruction. So this output code, let me copy paste this into a terminal. So I'm going to use the editor of 2024. So Vim HTML. So I'm just going to paste this thing into that and just save it out. And on the browser, I'll just try to open this up. And you can see that when I hover over this thing, it shows the arrows, and then quick and brown and so on. And when I hover out of it, it goes away. So that's a correctly rendered version of it. Now when I click on it, it shows the attention scores as just as I asked for. And maybe there's a little bit of rendering, like it's overlapping, but other than that, it's actually much better than what I could have done. Yeah, so this model did really nicely. I think this can be a really useful tool for me to come up with a bunch of different visualization tools for my new teaching sessions. The first example I have is very simple. This just counting the letter R's in a word strawberry. So let's start with the traditional, like existing model, GPT-4o. So as you can see, the model fails on this. There are 3 R's, but the model says there are only 2 R's. So why does this advanced model like GPT-4o makes such a simple mistake? That's because models like this are built to process the text, not with the characters or words. It's somewhere between, sometimes called a subword. So if we ask the question to a model, a question that involves understanding the notion of characters and words, the model can really just make mistakes because it's not really built for that. So now let's go on to our new model and type in the same problem. This is an O1 preview, which is a reasoning model. So unlike the GPT-4o, it starts thinking about this problem before outputting the answer. And now it outputs the answer. There are 3 R's in the word strawberry. So that's the correct answer. And this example shows that even for seemingly unrelated counting problem, having a reasoning built in can help avoiding the mistakes, because it can maybe look at its own output and review it and just be more careful and so on.
It's impossible to be an expert in every single gene. There's 20,000 genes. Like, you can't keep everything straight, but AI can. My name is Catherine Brownstein. I'm a geneticist here at Boston Children's Hospital. I'm also scientific director of the Manton Center for Orphan Disease Research. I deal with the N of 1 cases where no one has seen that presentation before. Patients don't know what's going on. They're really medical refugees in some way. it's like wing walking. Like you're seeing things and you're seeing genetic things, you're seeing phenotypic things, and you're trying to connect them, and none of it's been seen before, but like you think you are the only one in the world, but really sometimes there's a whole community. They just haven't come together yet. When before I would look up an article and then look up another article and then look up another article. Chat with reasoning is so much easier to use. It's just a quick prompt to summarize it for me and then summarize this part for me. I mean, it's just way, way faster. This is a case of excruciating pain in their bladder. We can't figure out why. So I can go here and say, can you tell me about citrate synthase? And it tells me that it is expressed in the bladder, and it could potentially be related to bladder health. So the decreased citrate synthase activity, oh, this is really smart, because I don't know from this variant if it's like knocking down activity or causing too much activity. It's actually really hard to figure that out sometimes. And so it gives both options, so I can think about both ways that it could be going. That's actually really cool. I go down a lot of rabbit holes that do not yield anything useful, and being able to increase the percentage of rabbit hole to useful information is killer. There's a level of obsession that all of us have. I think we also have the cases that keep us up at night where, you know, we really can't figure out why we can't figure it out. No case is ever closed.
Yeah, let's maybe demo a game, right? Can we like implement like a small game on HTML? What game do you like the most?
Let's go old school, Snake.
Oh, nice. Snake is a brilliant choice. Okay, let's try it out, shall we? Let's implement the snake with HTML, JS, CSS. Maybe let's use WASD to control the snake. Let's hit enter. All right, so wow, the model gives us a really long implementation of the snake game. Let's see how it goes.
Can you describe to me what it's doing?
So it basically thinks through like how we design the game, how to design the canvas, how to design the grid, and how to implement the different logic of this snake game. Let's copy the code, and let's HTML, and let's see what's this snake game. Okay, we have a snake game. It says press spacebar to start or restart, use WASD to control. Okay, we have this little green snake, and it tries to eat this red apple, I assume. Okay, let's make it more spicy.
Let's make it harder.
Yeah, let's make it harder. What are the options in your mind?
Can you put in some obstacles?
Oh, that's a brilliant choice, right? The snake game should have some obstacles. Do you have any design choice you want to make in the obstacles?
Maybe make the obstacles the letters AI.
Oh, that's nice. Let's see. Tell this model to add some obstacles, and they should form the letter AI. Right, now the model is thinking, and it returns us a new implementation that tries to further implement AI into the grid. All right, and then after outputting the code, it also gives us some description of what are the changes or the enhancements, and let's see whether the code works. All right, now it actually looks like a giant AI on the screen, and there are all the obstacles. So it's really cool, right?
Very cool.
Yeah.
It's exciting.
Yeah, it's a very exciting and smart model. And as you see that the model really tries to see or try to think about all the instructions I give to the model and tries to follow instructions and try to correct its own errors.
So the example I'm going to try out is almost a code cracking of a badly corrupted Korean sentence. So here I pasted in the prompt, and I'm asking the model to translate this badly corrupted Korean sentence to English. And as you can see, this is not a valid Korean sentence. So let's start with the existing model, GPT-4o, and see how it does. The model is just not able to understand this text, which is a valid response because this is not a valid language. So what's happening here? So Korean is an interesting language in that when we form a character, we can combine vowels and consonants, sometimes put the consonant at the bottom, and so on. One way to corrupt this character is to add in some extra unnecessary consonants to it. And that combination is so unnatural to native speakers, so they can just, when they see it, just automatically undo that change and understand the text. So this is character level corruption. We can do that at the phrase level, we can also do that at the sound level, and so on. People have come up with various methods like this, and I found them really interesting, so I adopted a few of them to create this example. So if you understand Korean, this part that I'm highlighting now, you can read it off as a 지구상 어떤 번역기도 읽을 수 없지만 한국인들은, and so on. I'm not going to read off the whole thing, but this is the idea. Koreans can read it, but the models find it so difficult to understand. So now let's go on to our new model, O1 preview, and see if reasoning can help solve this problem. So I typed in the same thing. Unlike GPT-4o, this model starts thinking through this problem before outputting the answer. So it's decoding the garbled text. So that's actually the right approach, because I gave a translation task, but the underlying task is actually decoding this problem. So it started off with the right path, and then I'm examining this text, deciphering the text. Deciphering is actually the right verb to use here, enhancing the translation, and then actually it starts unpacking some part of it. So here, 모음과 자음의 다양한 변환으로, and so on. This is already an decrypted part of this, and then once the model figures it out, that part, everything else is just easy enough. So it does the other sentence too, and so let's close this thought. So it thought for 15 seconds. The final translation the model output is, no translator on earth can do this, but Koreans can easily recognize it. There's a method of encrypting Hangul by inputting various transformations of vowels and consonants. It creates a way to make it look different on the surface. It can even confuse AI models. I think this is a perfect translation of the sentence. So this illustrates how general purpose reasoning models like O1 preview can help seemingly unrelated questions like this, which is almost like a code cracking. So I hope this illustrates how reasoning can be a powerful tool for solving your problems.
I really like this puzzle because it's been a puzzle from a computer game I've been playing as a kid. The riddle reads as, a princess is as old as the prince will be when the princess is twice as old as the prince was when the princess's age was half the sum of their present age. Even if it even reads hard, it's kind of like it takes a while for a human to understand and translate this problem into how to actually solve it. The question is, what is the age of the prince and the princess? And let's ask our reasoning model how it will do with that. And again, we can observe a little bit its thinking process through like decoding the problem, understanding what are the equations that the ages of prince and princess need to fulfill, and let's see for how long the model will need to think about it. Just similarly as humans sometimes think longer and shorter on a problem, our models do the same thing, and after a while, I hope the model will give us a correct answer here. The model is still thinking about it. It's not the easiest problem, but we got the answer just right now. The model also walks us through the solution in this case. What are the variables? What are the conditions? how to translate this problem into English, and how to solve those equations where they are just real time. Together we even got a message about verification, and we got the answer where the prince's age is 6 times k for any natural number k, and the princess's age is 8 times k, that natural age, which also like is the correct solution for the problem in that game.
So one of my favorite puzzles that I would do when I was a little kid is called a nonogram, where you're given an empty grid and then some numerical clues that tell you which squares in the grid you have to fill in. And I thought we could have the model play a little game where it first generates a puzzle to solve, then we ask another instance of the model to try to solve the problem that it generated. So yeah, I'll ask it, generate, say, a 5x5 nonogram where the final answer is the letter M. We'll see what it comes up with. All right, we see it just gave us a little puzzle. We'll go ahead and copy this, open up another window of O1, ask it, solve the following puzzle, and let's say, visualize the answer in some pretty way. Why not? This puzzle doesn't look like it's too hard, but the way that a nonogram works is for each row and each column, you're given a list of numbers, and the numbers tell you how many squares are filled in. And if the squares are consecutive, then you'll see like a 2 for 2 consecutive squares. If there's a space between them, you'll see a 1, 1. And so you're supposed to just try to figure out which squares do I indeed have to fill in. And it looks like the model got this right. Illustrated a nice little letter M. But I think one of the things that is like nice about examples like this is it's similar to like Sudoku or a crossword, for example, where you have to kind of make a guess and then see if that's a right guess or a wrong guess, and then backtrack if you get it wrong. And so any type of task where you kind of have to search through a space where you have different pieces pointing in different directions, but there are mutual dependencies, so you might get a bit of information that tells you that these 2 pieces contradict each other. Like a model like O1 is really good at trying to refine the search space here.
I can kind of easily follow the reasoning. I don't need to trust the result. I can just look, what did it do?
Who are you?
Oh wow, who are you? Very big question. I'm Mario Krenn. I'm a quantum physicist. So quantum physics is the study of the smallest particles. I want to understand how the world works. Here I would ask a question about the application of a certain quantum operator, which I know previous models like GPT-4 would very likely fail in this task. But here, in contrast to answers from GPT-4, this one gives me very detailed mathematics. This is correct. That makes sense. Here I think it tries to do something incredibly difficult. The really interesting thing is, how does the world work? But if you know how the world works, it helps you potentially to build new technologies.
The first of the problem I would like to show is an interesting common sense reasoning thing that all the previous type of large language models didn't do that great, which is about physics and about physical objects and their relationships. The problem reads, assuming the laws of physics on Earth, a small strawberry is put in a normal cup and the cup is placed upside down on a table. Someone then takes the cup and puts it inside the microwave. where is the strawberry, and explain the reasoning behind it. It's a simple problem. Every human will know straight away what is the answer, but it's something that language models are struggling a little bit, and then we can see how does this model do it. And we can also like a little bit have a glimpse on what is happening in the head of the model, and we also get a pretty nice answer of like, you know, what happened, why it happened in this particular scenario. The model needed to spend a little bit more time thinking about it and analyzing what did actually happen there. It couldn't. The model has a bit of a harder time thinking, especially about like scenarios involving physical objects, and then you need a little bit more time thinking for that.
It takes a lot of effort to build code that runs consistently and works very well, right? And I think the thing that's really, really exciting now is every human is going to be able to build way more. And there's so much more to build, and that's what gets me really excited. Yeah, I'm Scott Wu. I'm the CEO and co-founder at Cognition. The thing that's interesting about programming is that it's changed in shape like over and over the last 50 years. Programming used to be punch cards, and people used to, I mean, that was how it was first done, right? Along the way, there were all these different technologies, the internet and cloud and mobile and so on. I'd say as a whole, it's only gotten easier to produce code and to produce real programs. Being able to write code out line by line is one thing, but also being able to understand and interpret logs, being able to navigate and run commands that actually, affect the real world is a big part of programming. This new model O1 is really able to process and make decisions in a more human-like way. We're getting a glimpse into a new generation of models. We worked closely with OpenAI on iterating on it and giving our feedback and testing it out. What we found was that O1 was just incredible at this kind of reasoning. I guess I should explain what Devin is and stuff from the beginning. Yeah. Okay, cool. Yeah, so, at Cognition AI, we're building Devin, the first fully autonomous software agent. And, what that means is that Devin is able to go and build tasks from scratch, and is able to work on problems the same way that a software engineer would. And so here, actually, I asked Devin, to analyze the sentiment of this tweet, to use a few different ML services out there, to run those out of the box and break down this particular piece of text and understand what the sentiment is. And so first, Devin will make a plan of how it plans to approach this problem. Yeah, and so here, it had some trouble fetching it from the browser, and so then instead it decided to go and go through the API and fetch the tweet that way, right? And all of these little decisions, things like that happen all the time. You can really see here how much this human-like reasoning makes a difference. Finally, it's able to get this all the way through. It says the predominant emotion of this tweet is happiness. The soul of programming has always been the ability to take your ideas and turn them into reality. And now you're going to be able to do that much faster and cleaner than ever before.
I want to show an example of a coding prompt that O1 Preview is able to do, but previous models might struggle with. And the coding prompt is to write the code for a very simple video game called Squirrel Finder. And the reason O1 Preview is better at doing prompts like this is when it wants to write a piece of code, it thinks before giving the final answer. So it can use the thinking process to plan out the structure of the code, make sure it fits the constraints. So let's try pasting this in. And to give a brief overview of the prompt, the game Squirrel Finder basically has a koala that you can move using the arrow keys. Strawberries spawn every second and they bounce around, and you want to avoid the strawberries. After 3 seconds, a squirrel icon comes up, and you want to find the squirrel to win. And there are a few other instructions like putting OpenAI in the game screen and displaying instructions before the game starts, etc. So first you can see that the model thought for 21 seconds before giving the final answer. And you could see that during its thinking process, it is gathering details on the game's layout, mapping out the instructions, setting up the screen, etc. And so here's the code that it gave. And I will paste it into a window, and we'll see if it works. So you've seen there's instructions, and let's try to play the game. Oh, the squirrel came very quickly. but oops, this time I was hit by a strawberry. Let's try again. You can see that the strawberries are appearing, and let's see if I can win by finding the squirrel. Looks like I won. So I want to talk about a prompt that GPT-4o really struggles with, but our new model O1 preview can do pretty well. And the prompt is simple. It's write a 6-line poem about squirrels playing koalas at soccer that meets the following constraints. In line 2, the last word should end with I. In line 3, the second word begins with U. In line 5, the second to last word is eucalyptus. And in the final line, each word has 2 syllables. So first we'll try with GPT-4o. And we'll see that the answer from GPT-4o meets some of the constraints, but not all of them. The reason it's hard for GPT-4o is it has to get it correct on the first try. It can't check that it meets the constraints and then revise the poem. Now let's try the same poem with O1 preview. And we'll see that differing from GPT-4o, O1 preview starts thinking before giving the final answer. And you can view a summary of the thinking process of the model. So first you could see it's starting to think about different words for rhyming. Then you could see it wants to make sure the last word matches I. It thinks about words like alibi. It's analyzing word endings, and it's thinking about words like ski. Then it's piecing together phrases, but it thinks they don't quite fit. It's thinking about phrases where the second word starts with you. Then it's tweaking the words to fit the 2-syllable rule for line 6. It's digging into various 2-syllable word combinations. Then it's checking whether the poem aligns with all the guidelines. It's working through the poem to analyze the soccer aspect. And now let's look at the final poem. So in the second line, the word safari does end with I. In the third line, the second word unleash does begin with you. In the second to last line, eucalyptus, the second to last word is eucalyptus. And finally, in the final line, under moonlight creatures scatter, indeed each word has 2 syllables. So this is an example of a prompt where, because the model can generate candidates and do reasoning before giving the final answer, it's able to give a higher quality response.